All right, so good evening and welcome everyone to join us. And tonight we have a guest speakers, Habibi and also Feras from Dassault Systems. And we will actually have them to present one of the research paper, right? That is
Yep.
combining the MBSE also with AI. And we will actually look into the actual applications. So the event will be recorded and the praise is yours. Go ahead.
Yep. Thank you very much, Robert. And everyone, good evening. So thank you for joining us in this presentation. So we will talk about the roles of LLM, large language model, NLP, natural language processing, and ontology application in systems engineering and model-based system engineering. Allow me to introduce myself. My name is Habibi Hussain Arifin. So currently, my position in Dassault System as Asia Pacific South manufacturing team. So I'm one of the technical consultant that focus ourselves in product lifecycles management (PLM), and then the ecosystems of product lifecycle management, including model-based system engineering, and also system engineering as well. Yeah, computer. So we also have a research, some side research about the AI power system engineering or AI power model-based system engineering. So one of those research that we work together with my colleagues later, Firas, we have those one of the result of that research that will be shown in this presentation. So the next speaker is Firas. So Firas, the stage is yours.
Thank you, Habibi. Hello, everyone. Good to see you all. My name is Firas. I've been working in the data science and AI domain for the last 10 years. Now I lead the technical sales team in Dassault System across Asia. I'm based in Singapore, and I'm happy today to present to you with Habibi this very important topic: how can AI, with its different form, LLM, NLP, and the different technology that exist, help you for the model-based system engineering. So thank you for joining, and hopefully it will be a very fruitful session for you.
Thank you, Firas. So the main reference of this paper is the paper that we just published during the INCOSE Asia Oceania conference in Singapore, I think in early of this month. So some of the content of this presentation is the future work of this main reference. So you will see we try to improve, based on the future work and limitation that we found during our research. So we try to improve them, and then we put that the improvement part in this presentation. So this is the outline of the presentation. So we break down into four main topics. The first one, we talk about the background, the trends of AI in both either in system engineering and also model-based system engineering. So we will continue with the specific role or specific application of natural language processing and ontology, specifically in requirement engineering. Continue to the role of LLM also in requirement engineering. So we will see what LLM can do in requirement engineering, and then continuously using LLM or Gen AI for the system architecture. So it's the process after the requirement engineering. And then we will close with the key takeaway and also Q&A if you have any questions. Now, first of all, before we talk about the main topic, we want to give you some background about some terminology that we use in this presentation. For example, the first terminology is about mission critical system. So a mission critical system is actually a system that must work for the mission to succeed. So there is another critical system, for example, safety critical systems, right? So if this system fail, so it means that the mission is also fail. So it can be the main system or the support system that caused the failure. So basically, we need to understand first what is the definition of mission critical system in aerospace and defense context. The second terminology is about system architecture. So this is the second term that if you are not familiar about the system architecture, so the system architecture is actually an architecture that used to define system behavior and structure characteristics in accordance with the derived requirement. So basically, if you're aware of system modeling language, so the system model language, there are actually three main pillars of system modeling language, SysML, which is the requirement pillar, the structure pillar, and the behavior pillar. And also there is another pillar called the parametric pillar, right, in SysML version 1. So is actually correspondent to that SysML system model language pillar. So this is what we mean by the system architecture in this presentation. Now there are other terminology that specifically used for our AI application. So I will give to Firas back to explain about these three terminology. Over to you, Firas.
Thank you. So before we talk about MBSE and AI in MBSE, it's very important to understand together those basic AI concepts. So I will start from left to right. First, terminology is LLM, large language models. I assume that now it's become very famous. So basically, LLMs are AI models which are trained on a huge amount of data. They learn the patterns in language, how words connect, how ideas flow, and they can help you answer to questions, write text, summarize information, and even sometimes explain concepts. Of course, the simple examples that we all have in mind can be ChatGPT, Grok, Gemini, Mistral, DeepSeek, you name it. So when you ask a question, they generate a reply predicting every time the next word. Now we go to NLP. NLP is another field, so it's part of AI, and it's another field that teaches computers to understand human language. It includes things like finding key information, detecting the meaning or the tone or the sentiment of a sentence, and basically turn it unstructured data, text, into more structured data. For example, when a tool or an application pulls some dates from maybe an email or from text, that's certainly using some NLP technology. Now, ontology. For those of you who never heard it, it may sound complex terminology, but it's actually very easy to understand. So an ontology is basically a clean and a clear map of knowledge. It will help you understand what things exist in which domain, how they relate to each other. You can think about it like a dictionary plus the different relationship between those terminologies. So in simple terms, LLM generate and understand language. NLP organizes and interprets the language, and ontology give you the meaning and the structure to this knowledge. This is why together they form the foundation of many modern AI applications. And this is why we think that AI augmented MBSE can be reached thanks to those three different technologies. And we will showcase to you how and how Dassault Systèmes as a company can help you on that.
Thank you, Firas. So before we continue to our the first application of NLP and also ontology, so let me walk you through these slides to discuss about the three common AI application or the trend in system engineering and model-based in system engineering. So based on our literature study, the first on the left-hand side, we see the AI is helping us to handle large and complex documentation. So modern systems rely on huge stack of standard and regulation. For example, the INCOSE System Engineering Handbook, ISO 26262, for example, for automotive, ARP 4754B, for example, for civil aviation, and then MIL standard for the military or defense standard, and so on. So this is based on the research of Morera 2025 to show how LLM can quickly or helping identify the content pattern to summarize and compare this document to reduce the manual effort. Now, the second application in the center, number 2, is the LLM for requirement engineering, or as known as the LLM for RE. So this is summarized by Ali Khan, Qayyum, and Dar in 2024. So here, the LLM assists across the requirement engineering life cycles, for example, starting from elicitation, analysis, tracing, prioritization, validation, and even drafting the requirement specification. Now, the third application, the last one, is AI to support design pattern generation for configuration exploration. So there are two possible use cases here. The first one is for system architecture design generation, and the second one for text to CAD or text to the 3D model. So you might see that now, some of Dassault system technology is actually also go to this direction as well, right? Now, the next slides. So on these slides, we focus on a common AI use case in requirement engineering and system architecture. So based on those use cases, the 3 use cases that we studied so far in the previous slide, we take out and then we classify 2 major use cases for requirement engineering and system architecture. So the first use case, we start on the left with the specification or contract document, which is mainly captured in the like a PDF, or it's a kind of like Excel, either it's a structured document form or unstructured document form. So today, this is often hundreds of pages of natural language, right? So, and then we continue with use case 1 to show how AI can help. So we use some technique to perform requirement extraction from the document, right? And then next in the middle, those extracted requirements go through requirement analysis and are refined into more clear form of the requirement specification, right? So in this level, in this phase, sometimes we do requirement prioritization and also requirement classification. So later Firas will show you how we can leverage AI power, the power of AI to do this requirement prioritization and also the classification under requirement analysis. Now, the next one is the use case to that show you once we have in a set of requirement in more structured form, AI can help you to generate a system architecture candidate. So it's a kind of like a pattern to generate the system architecture and then continuously to keep the traceability between the system architecture element back to the requirement specification itself, which is one of the most important element inside any system architecture. Now, however, according to our literature study, if we use the trend of LLM only like a Gen AI in system engineering or model-based system engineering, so there are some major limitation that we found so far. So if you see here, there are 3 major pain points of Gen AI or LLM in mission critical system, which need explainability, traceability, and also a good governance. So the first one is lack of traceability when the output are not tied to valid system architecture that construct with some specification, for example, like system modeling language, either SysML version 1 or version 2, or you might use another system architecture specification language. So it doesn't matter what language, but the output is mainly have to be tied to this specification meta model. The second one is a lack of explainability, because due to the nature of neural network memory, for example, like Gen AI or LLM, is actually we consider as a black box AI. And the third one, of course, because of the lack of traceability and lack of explainability, is resulting of the lack of compliance, because it's required explainability in order for human to do the human review or critical review. Okay. So this is the major limitation. So the problem of this pain point is basically because of two major reasons. The first one is a lack of context. So whenever we use AI, we jump into technology without understanding the context. And the second one, since the neural network family is a data-driven AI, it means that we have to be careful about the data gaps, or what we know that as imbalanced data. Yeah, imbalanced data or balancing data. That is the two things that the first reasons of why most of AI application for Gen AI is fail. And then the second one is the process definition of the process. The dependency of the process is become another reason. So because we not predefine the process of using the AI or doing the automation with AI, especially with LLM, it's harder, it's difficult for human to do governance for the input and also the output of the AI automation itself. Now, if we go to the previous study, our paper, so based on this, the future work that we defined on that paper, we want to zoom on two key limitations that highlight in the yellow boxes. So the first one is with LLM, the semantic check are only partial, because with LLM is actually they don't do any semantic check unless we train our model to do semantic check. But because of the lack of explainability, it's very difficult to know that which semantic are correct and which semantic is not correct. So because of this reason, we are applying another method, for example, another tool to do semantic accuracy check. This is what we know as the gut railing. So this semantic accuracy check is actually we try to leverage the rules that come from the INCOSE Guide to Writing Requirement Rules version 4 that published in 2023. So we extract this document and then create with the technology like NLP and also Ontology, we do this semantic accuracy check. So this will be explained by Firas later and also demonstrated by Firas. And then the second one, since LLM has that limitation about explainability, right, because of the black box, nature. So we are actually trying to leveraging to see in which application that LLM shall be applied, and then in which application Ontology and NLP and the other, for example, the other algorithm or the other AI tool, can complement, the limitation of LLM itself. So this is basically two main focus of this presentation. So what we propose so far, right? As explained under the future work, so there are three approaches that we took as the next step. So the first one, we use the multi-agent system architecture. So as you know that this is a kind of like another form of agentic AI. So the multi-agent orchestrations to align with the MBSE pillar. For example, like if we have some methodology or if we use any specification like a modeling language specification like a system modeling language or SysML, so we can we can include the context of that, both methodology and also language specification into the multi-agent architecture to construct, the context and also the process governance of that AI automation. Now, the second one is we using the NLP and also ontology for the use case one. What is use case one? Use case one is the requirement extraction and analysis, including requirement check and also requirement classification. Now, use case 3 is the approach number 3 is to use or leverage the LLM for the rest of the field when we need something, when we need LLM to suggest of what? Suggest of, for example, to suggest requirement or to create a draft of requirement or to create a pattern or pattern draft of the system architecture. So because of the nature of the generation of LLM, so we use them to generate, to suggest, to suggest requirement and also system architecture. Now, what is the example of the multi-agent approach? So the multi-agent approach is actually is not a new thing. So it's actually introduced, I forget, yeah, it's a long time back that actually borrow the concept of the object-oriented, right? So in these multi-agent samples, so we use centralized supervising or centralized orchestration of multi-agent system. So it means that we use one supervisor agent to control the process of the automation. So if you're aware of the technology, for example, like LangChain or LangGraph, so it's basically practically it's a similar. But in this case, instead of using LangChain or LangGraph classification, we use SysML or system modeling language itself, because we can directly include the meta model, for example, like requirement meta model, systems that come from the block SysML block meta model, function that come from, like, for example, activity meta model, or parameter that come from the value property of a block meta model. So each of these agents can use or leverage different type of AI technology. So this is what we mean by agent orchestration, right? So if you see the sample of the dependency here, it means that the process of, between this agent, they are not independent, so they're dependent. For example, in order to suggest, for example, a function, you need to have the requirement or functional requirement first to generate the function. And also, you cannot have a parameter if you not define first what function or what function, or for example, what structure that you have that to refine the requirement itself. So this is to show the example on how we can create dependent process inside multi-agent architecture. Now, how to positioning all the technology that we mentioned, LLM, NLP, and also ontology. So we split this flow use case 1 as use case 2 into two technology. So the first one, starting when we deal with the unstructured document, like for example specification and contract document, go to requirement extraction to extract requirement specification as it is from the document, and then to continue to do requirement analysis, for example requirement classification, or requirements, for example, checking on the requirement rule, for example, or constraint. So we use NLP and ontology. And then we continue to use LLM in order to suggest us if there is any missing requirement, or is there any requirement that not complete that come from the contract document. So basically, we just use as an LLM in order to suggest, or generate if something missing. Now, the next application we continue is to leverage the power of LLM, since it is generative. So it means that it can generate a pattern of the requirement or pattern of system architecture, including suggest to us, to the modeler, how to keep the traceability from each of the requirement specification that we finalize from the requirement analysis back to the system architecture, because this traceability is critical to maintain, at last, because how we check whether our system architecture is correct or not correct is everything back to the requirement specification. So we use LLM to generate or to suggest us those traceability as well. So we not lose the traceability, because if we lose the traceability, right, it means that there is no way to check in where or from which requirement the system architecture was generated. Now, I will pass to Firas to go for the first use case of the role of natural language processing and ontology in requirement extraction and classification. Over to you, Firas.
Thank you, Habibi. Thank you for the clear explanation. And as mentioned, our objective here is just to showcase one of the examples where natural language processing and ontology can be useful for model-based system engineering. So we chose this use case of requirement extraction and classification, and I will detail it with some real customer cases and real videos that we offer in Dassault System Company. So next slide, you will see the end-to-end demonstration. If you can help me move to the next slide. Thank you. So we will focus on two main use cases. Of course, here we are talking about regulatory documents, requirements documents, where the customer will select the different, can be 10, 100,000 numbers, doesn't matter, of documents that we are analyzing. At the first step, we will show you how we are helping customers and engineers to extract and classify automatically those requirements from several types of documents. And once again, it can be different types. This is step one. Step two, how we are using also the same technology, natural language processing, to make sure that those documents are compliant with INCOSE rules. As Habibi mentioned, we see it as a guardrail to reassure that all the different requirements and compliance are correct. After that, in the same demonstration, we'll show, of course, once analyzed and validated, we can export it and we can collaborate between different engineers to finalize the project. So let's start with number one. Next slide. This is before number one, we wanted to show you some examples of ontologies. When I mentioned ontologies in general, so our technology, it comes with predefined taxonomies and ontologies that will help you to analyze all the different documents that you have. Once again, see it as you push all your unstructured data, PDF files or requirement that you have, or regulation that you have, or certification that you have, and automatically you will benefit from all the ontologies that we have already created, but also from the new ontologies that you can create, and all your unstructured data, wherever there is a word, if I take an example here, technology, mentioning IoT, they will be automatically categorized in that specific filter, in that specific ontology. So once again, see it as a library which will help you easily navigate into your huge number of unstructured data. With this, we move to the next slide, which is use case number one. So this use case, as we mentioned before, it is about really helping helping the engineers to analyze all the different unstructured data, the requirement specifically here, using NLP and using ontology. The purpose is to make you save time and boost your productivity with a trustable technology without any black box to make you quickly analyze your unstructured data and make sense of it. Let's launch the video. So in this use case, we are analyzing, as you can see here, multiple unstructured data in the left. Automatically, what we are doing is, I don't know if this is moving on your side. Yeah, thank you. So automatically, our system detected all the terminologies in those documents, of those thousands of documents, and putting them in different ontologies, in different taxonomies and filtering capabilities. So as an engineer, it's easy for me to navigate and to understand those documents in the screen. So we can, as an example, select which document are talking about the specific topic, which documents are talking about the specific chemical element, which documents are written in which language, which documents are written with which department, author, etc., etc. So automatically transforming my huge amount of unstructured data to structured data and filtering capabilities to help me navigate and understand the different documents and make me, at the end, more productive in my job. So this is number one. Once done, number two, what we will do in the few seconds is also help the users automatically detect all the different requirements, instruction, and permission with only natural language processing. So from all those documents, automatically we detected which one are the requirements, which are not requirements, like are just permissions, and help me quickly visualize them in a table view, navigate into them if I need to reread the documents, and make sure that basically I have the right list of requirements. We have also multiple other capabilities for these customers where we are linking the different requirement to the real parts and products in our what we call virtual twin or in our system engineering. So we know that this document is linked to that part, or it is linked to that specific department, or if even it's linked to that specific other document that we have into the system. So we can explore those references between all the different documents that we have. And once again, in summary, it is helping you to explore all the data that you have in an unstructured way using natural language processing, which means using a trustable technology to help you identify, navigate into your requirements. So this is step one. Now let's move to step two with this second use case. As Habibi mentioned, one of the examples that we wanted to show today, we have multiple of them. We wanted to highlight the fact that NLP can also help you make sure that you are compliant with all the different INCOSE rules, as an example, by clarifying and correcting the different formulas that you may have, and this is done automatically with our technology. So the ROI is obvious. Basically, we're trying to help avoid major losses of time, and the video goes as the following. We, first of all, launch our technology and give it all the documents that we have. And automatically, what you see on the left, we have automatically all the different rules. We are not satisfied. And this is done using the natural language processing technology, which analyzed all the different words, all the different sentences, and detected that multiple rules are not satisfied and they may need your attention. In this video, we'll show a couple of examples. Feel free if you have any question later on. Example here, the passive voice rule R2, where it will show you a couple of examples which written in a passive voice, like shall be tested or shall be improved. This kind of examples are automatically detected and highlighted in their context, in the requirement. There is some other example with other rules, the superfluous infinitives. When you use this kind of terminology, is also not following some rules from INCOSE to be used to protect or this kind of terminologies. So we are automatically detecting those kind of wording and making sure that they are following the rules or not. A third example here is the measurable. Here as an example, we're talking about it should be user-friendly. It's not really a measurable requirement. So we are highlighting it to the user. So everyone can work together to make sure that we have one unique view listed in one specific dashboard or report, and we can make sure as a team to rewrite those requirements and to make sure that everything is aligned with the different INCOSE standards and rules that we have. So with this, I will pass it back to you, Habibi.
Thank you, Viras. So if you have any questions about this technology, the natural language processing is also ontology for use case one. So please ask Firas, in the last of the discussion. So the second one is the role of large language model in requirement pattern generation. So before we continue to the next step, which is the transition between the use case one for the requirement engineering, and then to go to the system architecture. So basically, we define the input, process, and output that we extract from the document at the first place, right? So in either you use LLM to extract, or you use technology like NLP to extract the requirements. So it's actually you need to have a middle process for human to allow human to do the review before we do any model generation. Either it is a SysML requirements generation that come from NLP or come from the NLP check with the INCOSE rule. We need to have those review first that you see before Firas show us, right? That we can export those, into Excel form, and then we can take that Excel form and then automatically import those Excel form and then automatically generate to become the your part of the system architecture starting from the requirement. So basically, this is the simple IPO, input, process, output, from the beginning, from the unstructured document, and become the system architecture, including the traceability, requirement traceability that we will see later. Now, some of the application that we take, for example, for LLM is, for example, if we inject LLM and also NLP, to be the application of implementation of the requirement agent. So in this case, the requirement agent will be injected with the SysML meta model for the requirements for the requirement view. So in this case, it will allow the requirement agent to understand what attribute, what specification. For example, like the ID of the requirement, name of the requirement, the documentation of the requirement, the text of the requirement, the classification of the requirement, right? You can inject all of that information in the meta model of the requirement agent. So the requirement agent will understand about SysML or SysML meta model for the requirement element. That's the example of how we inject the context to the requirement agent. Now, continue to the next step is after the transition between the requirement engineering. So we actually continue to use the requirement specification, the final requirement specification, to generate the system architecture pattern. So in this case, we leverage the power of the rest of the agent. Like for example, if we have definition of the system agent, function agent, or parametric agent. So this agent are considered simple, right? So basically, you can create also an agent depending on the methodology that you use. For example, I'm currently design one set of agent for system architecture methodology. For example, the one that comes from NASA, like OOSEM, Object-Oriented System Engineering Methodology. So you can also create an agent for each of that methodology, where you have, for example, conceptual model agent, functional model agent, logical model agent, system requirement model agent, or for example, the other one is a physical implementation requirement agent, for example. So it's not necessary to have this, this set of agent, but you can align this agent, also the multi-agent architecture, together with the methodology that you use. Or for example, if you use the Dassault system magic grid methodology, so we have, for example, the problem domain, black box definition, white box definition, solution layer definition. So you can have agent for each of that domain or each of that view, right? So later, every time you generate the system architecture pattern, you can tell your agent the dependent process. Like for example, in Magic Grid, you need to start with the requirement and with the stakeholder needs, and then after that you need to go to use case. From the use case, you need to define system context. So you can define that process dependency later on in your multi-agent architecture for each of the agent, because each of the agent have different pattern, they have different information to capture. So you can teach each of the agent, or maybe you can leverage not only LLM, but another technology, either NLP, expert system, for example, NLP, ontology, or maybe, for example, expert system, like a rule-based, for example, anything that you want to apply depending on the needs of each of the agent. Now, the sample we show after we construct our multi-agent, we leverage every technology that we think that the best for each of the agent, like requirement extraction, NLP is the best, for example, right? Based on our evaluation. And then requirement suggestion, requirement generation, LLM is also the can be considered as the solution for system architecture. Since we starting from zero from zero information, so or maybe we just read from the requirement specification. So it means that we can use LLM, for example, to extract them, or maybe we use ontology to extract the information of the system architecture pattern, for example. So it depends, right? However, this slide is show you the sample result, and then I'm going to run one demonstration, one prototype that I'll build within our tool called Katia Magic, right? Or you know them as in the past as a Cameo system modeler or Cameo, or you might also know this tool as the Magic Draw. So in this sample, is actually we already teach the multi-agent architecture, each of the multi-agent architecture, and then injected, the SysML version 1 meta model, which is the requirement element, block element, SysML activity element to represent function, and also value property to represent parameter. So each of that, element will be extracted first from the requirement, and then from the requirement, we will continue to identify, for example, the system or the subsystem or the component, and then we keep the tracing from the block back to the requirement by refine the relationship, for example, and then for the function, also for the function allocation back to block, for example, or back to the system or subsystem and component, and also which parameter that's it or that's owned by which system block, for example, right? Or systems, system block or subsystem block. So in this example, as you can see here, we not only generate the pattern only for example, the system or requirement or function, but also include, automatically generate the relationship or the traceability between the requirements to block or requirements to the structure. You see the relationship come here, right? And including the function allocation to the block, right? Or function allocation to the component or subsystem, and then include the function refinement back to the requirement itself. So it means that imagine that if you generate this system architecture, you ask generative AI, now you can check, you can do the review, right, by identifying the traceability from the traceability. So you know which function come from which requirement. So you not lose sight of what has been generated and how to review them because of the traceability. So that is actually the end of our demonstration today. So this is just to summarize the result that we get so far from the use case number 2 for LLM for system architecture. So basically, we can use LLM, for example, to generate or to suggest the requirements that cannot be extracted from the document or missing from the document. And then the second one, we can use LLM or Gen AI to generate the pattern of the system architecture. And of course, LLM again can be used to suggest us the traceability between the system architecture they generated back to the requirement, as the origin source of truth that we need to trace along when we do any system architecture. Now, for the key takeaway, I will give back to my colleague Firas to close, this presentation. Back to you, Firas.
Well, thank you very much, and thank you everyone for your time and connecting during night for some of you. So the key message here is for some mission critical systems, we should use the right tool for the right topic. This is why, together with Habibi, we wanted to present to you different examples based on AI and how can we use them in the right time to reduce the risk and maximize the productivity of every engineer. So in summary, LLM and this new technology, of course, is amazing. It is changing the world, no doubt on it. However, with today's technology, there is some limitation, and per definition and per design, this black box of it leave us to go and use other types of technologies under AI, like natural language processing with the ontology to enhance our insurance for some use cases, like the one that you showed today, a requirement extraction, INCOSE rules check, and others. So our purpose is to use NLP ontology in the right timing, use LLM for the use cases that Habibi mentioned to you very clearly, and of course, without forgetting it, always a human in the loop to validate what AI produce, to manage the different risks. Once again, for those high-level systems and for those mission-critical use cases, we need to be always using all the different technologies, a human in the loop, and this is why we call the session Why Go Alone if Better Together. So thank you for your time. We still have 10 to 15 minutes of questions. Please do not hesitate.
Thanks very much, Faris and Habibi, for that interesting demonstrations and also the theory behind it, how it works. So it is open for all the people to actually ask any questions. You can, unmute yourself if you have any questions, or you can also type your question into the chat box.
Yes, Yu-Sing here. Thank you for your presentation. It's very exciting. I got three questions. One is, do you detect conflict of requirements?
At this moment, no. But we put
Not the conflict,
already,
okay.
yeah, not. But I read one paper to talk about that, and we already put under our future work. If you have
Okay.
any idea, maybe for example, how we can detect conflict, for example, from the semantic point of view, I think it's something good to discuss and to improve, this type of work.
Okay. My second question is, what do you mean by INCOSE rules?
So the INCOSE has one document, the writings to requirements, guide, right?
Oh no,
I think
that
it's
guide. Okay.
guide. Yeah,
Understand.
yeah,
Okay.
yeah. So
So it's
that guide,
the requirement manual you're talking about.
yes.
Okay.
So that guide is actually there are I think 40 somethings a kind of guide, right? Guidance that our R&D industrial systems, we have one technology to capture those constraints, those guide, and then make it become measurable guide by
Okay.
using NLP technology.
Okay. My third question is, besides analyzing the text or the words from requirements, sometimes tender requirements also have pictures, image,
Okay.
figures. Do you put them in? Are you able to analyze those also?
I'm not sure what we have today, but I will give to Firas because he's the best talking about this type of technology in our solution.
Yeah, so thank you, Habibi, and thank you for the question. Today, the technology I presented is more for natural language, literally unstructured data, textual data. It's not about analyzing photos or videos. We do have in Dassault System other types of technology which does that, analyzing videos even for other different use cases. However, today we really focus it only on this semantic, exactly, yeah, and requirement extraction. So if you have any ideas or use cases, of course, please share it with us in the future, and we can get back to you if we do have a solution for it or not.
Okay, thank you.
Thank you.
Great. Anyone have any questions? I think we got someone.
Can you hear me?
Yeah.
Okay, then I can try one. Yeah. Maybe I can show my face whether it works.
Hi, sir.
I thought it's Dr. Kwok.
Yeah, that's why I show myself, because I don't know. I have to change some parameters somewhere in the Zoom. I have done similar things to what you are doing, but of course not in such a scale. You are a big company. Recently, I have done some extractors because we didn't have any tools. So when we don't have tools, I construct tools so that we can make the life easy, less miserable of a complete team. But the example that I have in my extraction is again, it's hundreds of documents, it's very big sizes. You are talking about bigger even potentially, but we are talking about how to deal with a big size of document, but extracting text alone is not enough. So I like using this point about putting images. You have to at least find a way to trace back to the images, but documents are much more than text. They are organized in chapter. I saw you are using the chapters, but I've seen in my latest iteration of a long project, I have seen tables with tables inside tables inside tables containing text, containing pictures. So you imagine the mess. So I have kind of scripted all this. So that was really a bit of hard. Luckily, we have a lot of libraries to do that nowadays, so it's a bit easier. But it's not LLM at all. So that's just something to share with you guys. That's my free gift for the day. The second one is I have also played quite a bit with SysML v2. I have in the past 6 months I have learned SysML v1. I'm now learning SysML v2, and I'm starting to generate stuff using tools. And I have done some AI on it. And I see, to me, SysML v2 is a revolution because you have a grammar which makes it very easy to jump to extract and to generate some element in the grammar form. So that's really a child's play. It's probably a bit easier, more difficult, but you guys know it upside down probably to do that in SysML v1. In SysML v1, I wouldn't want even to try because it's every tool has got its own syntax, so it's a nightmare. So as a constructor for you, it's probably worth it, but for anybody else, it's not, because you will jump from one tool to another one. But maybe that's something that might be of interest, is to, if you have something that allows to generate the syntax of SysML v1 to make it a library for people to be able to access. That's an idea, because there will be a lot of people in the coming months and years who will want to migrate their v1 to v2. So putting some little help on the way to help them jump. So if you were having something like a textual representation of v1, okay, I'm maybe putting my hand a little bit, I don't know what you've done behind, but it would be easier to map a v1 to a v2 using a transformation of two grammars. That would be also much easier, and that could benefit a big amount of people. Sorry, I was wrong.
Yeah.
So my question on that last one, there was a question hidden there. How did you do the generation of the v1 stereotype?
So at this moment, right? Basically we have in the library that I create so far is basically we put the semantic mapping between the textual that come from LLM to the meta model, like for example requirement meta model. So we have those mapping behind that we predefine for each of the model element that we identify, for example, right? And for example, for requirement, for block, for function, for example, in the form of activity, for value property, what are the rules behind value property? We have everything. However, I agree with you that I think the evolution will be under SysML version 2. So if you see the future work here, is actually version 2 will actually eliminate, at least minimize, the encoding and decoding between the text to the model, because the v2 itself is a text.
Yeah, that's
right.
Right.
It's actually a cut one process that you need to do semantic mapping. It's already cut that process. However, what I find is v2 at this moment, the things that we need to be careful is because of data-driven technology like LLM is very much depend on how how we train those to understand the syntax of V2. At this moment, I'm pretty sure that the data is still imbalanced. So I think it will take some time. I don't know how long. But if we can do some, like you say, some automation from V1, for example, from the text, and then somehow we can inject V2 inside that text, we have to create some automation for that. It will be very beneficial because, for example, in my example, I'm talking about combat management system. If you find in SysML version 2 combat management system, I'm pretty sure you will get 0 because there is no data of SysML version 2 for combat management system. But if you ask in general, can you create me this system requirement for combat management system? It will extract from textual, from any textual that people inject, or from the Wikipedia, from anywhere they're talking about combat system, or talking about tactical data link, or talking about, for example, strike fighter, for example. So it will have information there, but in the form of textual. So this is, I think, the limitation for V2 is about the data that we don't have today. It's imbalanced. I'm pretty sure it's still imbalanced today because everyone keep their own data, right? So we need to have automation from V1 and V2. Now, if you're aware, from the technology point of view, very sorry about this, I bring from the technology point of view, doesn't want to do selling at this tonight. KTA Magic has a capability to transform, to mapping from version 1 to version 2. For example, from block in V1, it automatically become part def or part definition in V2. We have technology to do that automatically at this moment. But some specification that not covered in V2, like for example, specific parametric, for example, in V2, the parametric change style. Actually, how you capture parametric in V2 is changing. So some of this element we cannot transform automatically. But don't worry, for V1 to V2, we have from the technology point of view, we have a way to transform that as of today.
Okay, thank you.
Yep.
Interesting.
Yep.
Anyone have any other questions? All right. If no, I'm very thank you tonight for everyone participations, and also special thanks to Habibi and Feras to spend their lifetimes also while they are sick, right? And on the business trip. So this section is actually recorded, and we will publish to the YouTube and also distribute to the people who already registered for this event. We have more people to register. I see some people join and drop out in the middle. But anyway, it will be show and share public. So Habib, if you have the presentations, please also share with me so I can share that information together at our community.
Yep.
All right. So thanks a lot for everyone, and
Thank
all
you.
have a good night. Bye-bye.
Thank
everyone.
you.
Thank you.
Bye-bye.
Bye-bye.
Bye. Thank you.
Thank you.
Thank you for
Bye-bye.
doing this.